We have all the operations now. Let's step back and look at the cost of each one. The next slides put real numbers on why heaps are fast. Build heap looks like n calls to a big O of log n routine. That would be big O of n log n, but that count is too high. Most nodes are near the bottom, where heapify does almost no work. Look at a 15-node tree grouped by height. At height 0 are the leaves, 8 of them. Heapify does 0 work on a leaf, so they contribute nothing. At height 1 there are 4 nodes. Each does about 1 unit of work. That is 4 in total. At height 2 there are only 2 nodes, each doing about 2 units. That is 4 again. At the top, height 3, there is just 1 node, the root. It does about 3 units. That is 3. Add up that table. About 11 sift down levels for 15 nodes, with up to 2 key comparisons each. That is still under 2n of work, nowhere near n times log n, which would be about 60. The reason is a race between two quantities. Going up one level, the number of nodes halves, but the work per node grows by only 1. That geometric decay beats the linear growth, so the sum over all levels is bounded by 2n, that is big O of n total, not big O of n log n. So in your own words, why is build heap big O of n rather than n times big O of log n? Pause and answer. Because only the few nodes near the root ever pay the full big O of log, and most nodes are cheap leaves and near leaves that sink one level or none. The summed work stays under 2n, so it is big O of n, not big O of n log n. This table sums up every heap operation, and why each one costs what it does. Peak max is big O of 1. The max is always at A at index 0, so we just read it. Insert is big O of log, and the new value bubbles up, and it climbs at most the tree height, which is floor of log base 2 of n. Extract max is also big, O of log, and the new root sinks down, again bounded by the tree height. Build heap is big, O of n, we just saw why. Summed over all heights, most nodes are cheap leaves. 2 more entries. Heap sort, which is 1 build plus n extracts, is big O of n log, and the build is big O of n, and then n extracts at big O of log n each. And arbitrary search, or deleting a value that is not the max, is big O of n. There is no ordering between siblings to use, so you have to scan. That is the one thing a heap is genuinely bad at, and it is worth remembering.